All right, this is assignment number 22. And I have skipped 4 and 7. So if you check my answer key, I did use limit notation for the definite integral, and I'm going to set it up, but I did not go over this year with you how to actually take these sums and then find the limit. I don't think we need that for our AP test. So you can ignore some of my answer key on this, but it is a good idea to set things up. So you do need to know how to find delta x. It's 3 minus negative 2 over n, so 5 over n. And you do need to know how to find an expression for f of x sub I. Remember, it's always f of a plus delta x times I. A in this problem is negative 2. It's f of negative 2 plus delta x we just found, 5 over n. You can put the I up there with it. And f of x is just the function x. So that's actually just going to be negative 2 plus 5i over n. So this definite integral is equal to the limit as n approaches infinity of the sum from I equals 1 to n of delta x times f of x sub I, which is negative 2 plus 5i over n. Now, I guess I probably should be putting the delta x at the end. I think that's how, because it's normally like f of x dx, and we're saying f of xi dx. So when you're looking for these answers in multiple choice problems, they will probably have the 5 over n on the right side for a lot of them, but it doesn't have to be like that. So I'm going to stop here for this. Sometimes I have you guys write out the first 4 terms or whatever. I'm just not going to do that for this one. Same thing for number 7. Let's go ahead and find delta x. It's 2 minus 1 over n. So it's 1 over n. F of x sub I is equal to f of a plus delta x times I. In this problem, a is 1. So f of 1 plus delta x is 1 over n times I will be I over n. And this f of x is a little more intricate. So we're subbing this expression in for x. So 1 plus I over n squared plus 1. That's f of x sub I. So this definite integral is exactly equal to its limit definition. The limit as n approaches infinity of the sum from I equals 1 to n of delta x times f of x sub I. Again, in my answer key that I posted, I've gone further with this. I've squared it out. I've had some rules to get rid of the summation, and then I took the limit. If you're curious about how to do that, I'd be happy to show you, but I don't think that we need it for our AP test. So I'm going to leave this here for now. So kind of along the same lines, you can see the notation in this textbook is a bit different than what we're used to seeing. It says write the limit as a definite integral on the interval a to b where c sub I is any point on the ith subinterval. So rather than what we just did, where they figure out, they're saying c sub I, I've been saying x sub I, rather than figuring out what that expression actually is, they're just leaving it as x sub I. So when we look at this, the integral on this one goes from negative 1 to 5. And the f of x, just replace c sub I with an x. They're just saying we can figure out x sub I is equal to this expression, but they haven't actually taken that step. Okay, so this is just 3x plus 10. I know the notation is weird. Make sure you write dx. I'm not sure what this is even about. I'm sure it means something very official. I don't think we need that for our AP exam. I think that's something this textbook is doing, which is certainly correct, but not something that I'm an expert on. Same idea with number 10. So this is the integral from 0 to 4. What's the f of x here? So anywhere I see a c sub I, I'm going to replace that with an x. So 6x times 4 minus x, the quantity squared. Remember to replace delta xi with dx. You don't get credit for an integrand if you don't write dx. All right, set up a definite integral that yields the area in the region. Do not evaluate the integral. So even though we could on some of these, we could on 15. We don't have, do we have the skills yet for 20? I don't remember at this point in the notes if we've done the integral of tangent yet. I guess that might be a little bit later. Anyway, the integral from negative 4 to 4 of 4 minus absolute value x dx. That's it. We're just setting it up. This one is the integral from 0 to pi over 4 of tangent x dx. Write the dx. It's the easiest thing to forget. It's the most common thing that is left off of problems for my students year to year. And it's something we definitely have to write to make this correct. 46. Use the table of values to estimate the integral from 0 to 6 of f of x dx. Use 3 equal subintervals. Part A is a left sum, so I don't have to guess about upper or lower. I'm just doing left. And part B is right, and part C is midpoint. If f is an increasing function, how does each estimate compare with its actual value? So we can see in this table that the values are increasing, but that's not guaranteed to mean that f increases for every decimal in between. So they're telling us if that's true, what do we know about that? Okay, if f is increasing, sometimes I just have to sketch this out for myself. A left sum will be a lower sum. So I'm just going to answer this here. How will it compare with the actual value? This will be lower than the actual value. Explain your reasoning because f is increasing. Because f is increasing and all rectangles would be under the curve. Okay, so what is the integral here? So the integral from 0 to 6 of f of x dx is approximately, so let's see, our delta x is 6 minus 0 over 3, so space of 2. So every width is going to have 2. And then you should be starting, because let's see, we're going on the left, right? So yeah, we should be starting here. So negative 6. And then we're going to be doing, let's see, start at 0. There we go. Start at 0, then do 2, then do 4, but we're not going to include the end point. So negative 6 plus 8 plus 30. And let's see, 2 plus 30, 32, so that's 64. All right, and the next one we need to do is a midpoint sum. How would the midpoint compare with the actual value? I think it should be, it's not going to be, we don't know for sure if it's going to be above or below. It should be somewhere in between. It should be the closest to the actual area. I'm not going to write all of that out though. So the integral from 0 to 6 of f of x dx, every rectangle would still have a width of 2. Now we're using the middle points in each rectangle, so 1, 3, and 5. So that's 0 plus 18 plus 50. Let's see, double 68 is 120 plus 16, so 176. Wait. Oops, I did. Okay, hold on. Sorry. I just did. Oh, wait, 120. 136. I just did these out of order, though. Sorry. This is C. C is the midpoint. And then B was supposed to be right. Right will be an overestimate, upper, higher than normal. And it will be 2 times. So on this one, we would start at 2 and then go to 4 and then go to 6. If it's confusing to do without drawing it, then just draw it. It's okay to have a sketch here. I'm just trying to save time on my video. This is 118 times 2, should be 236. Okay, 49. Consider the function f that is continuous on this interval for which the integral from 0 to 5 f of x equals 4. So I don't know what f of x looks like, but I know from 0 to 5 it's something positive and it's got an area of 4. Evaluate each integral. So if I do for part A, f of x plus 2, remember you should do this separately. Don't worry about you could think about what does this do if I shift up 2? It adds a rectangle. It's best to just split this up. So we know this is 4, and then this is 2, the height of 2, and you're doing that from a span of 0 to 5. So it's 2 times 5 minus 0. So this is 14 for part A. And for part B, I only have to do C and D. Well, whatever, I'm in it now, so I'm going to do B as well. Just bonus here. Now B, you kind of do have to think about a shift to the left, so let's sketch this one. What would happen if I move this to the left 2 units? So maybe now my function looks like this. It still has an area of 4 here. And actually, see how they've moved these? You went from 0, 5 to negative 2, 3. They shifted those bounds left as well, so it would still be 4 for that one. All right, so I wasn't supposed to do A, so fine, whatever. Okay, so let's do C. The integral from negative 5 to 5 if f is even. So we need to know our symmetry. Even means you have y-axis symmetry. So this part over here would get reflected and we would have a total of positive 8 area. If f is odd, whatever this area is here that makes 4, it goes origin symmetry. It reflects down here. You would have the exact opposite area on the other side. So that would be 0. Use the figure to fill in the blanks with a symbol less than, greater than, or equal to. The interval 1 to 5 is partitioned into n subintervals of equal width. X sub I is the left endpoint of the ith subinterval. So now this doesn't have limit notation, so this is just a Riemann sum. Just very fancy notation for a Riemann sum. We're stopping at n terms. So is the Riemann sum going to be an overestimate or an underestimate? So if we use left, sketch it in here, left is an overestimate, greater than. If I use the right endpoint, take a look there. The right endpoint is going to be underneath the curve, so the Riemann sum will be less than the actual area. And true or false? So if the norm of a partition, norm means the perpendicular of a partition approaches 0, then the number of subintervals approaches infinity. So what is that saying? The norm of a partition. So this is saying we've got rectangles. The norm is the width, I guess, of this. It's the width of each rectangle. So as delta x approaches 0, the number of subintervals approaches infinity, n approaches infinity. That's true. If you make the rectangle skinnier, you can get more of them in there. If f is increasing on a to b, then the minimum value of f on a to b is f of a. F is increasing on a to b. Minimum, not relative minimum, but minimum is f of a. That seems true to me. And then 77, find the constants a and b that maximize the value of this. Explain. I think the fastest way to do this is just graphically. This is one we can graph very easily. Here is the 1 minus x squared graph. It's a parabola. It's got zeros of plus or minus 1. Hits a max of 1 right there. So what would those have to be? Well, the maximum positive area goes from negative 1 to 1. So a equals negative 1, b equals 1. I'm sure you could do this with optimization, but you really don't need to. You can check my answer key if you want to see the optimization, but the largest positive area would have to be from negative 1 to 1. All right, I hope that helps. Come in and see me if you need extra help on any of this.